What is the cooling rate in injection molding? The cooling rate is a measure of how quickly the temperature of a material decreases during the injection molding process. It is an important factor in the quality and properties of the finished part, as the cooling rate affects the crystallinity, strength, and dimensional accuracy of the material. Several factors can influence the cooling rate in plastic injection molding, including design of plastic products, mainly the wall thickness of plastic products. The thicker the product, the longer the cooling time. Generally speaking, the cooling time is proportional to the square of the thickness of the plastic product, or proportional to the 1.6 power of the diameter of the largest flow channel. That is, the thickness of the plastic product is doubled, and the cooling time is increased by 4 times. Mold material, including mold core, cavity material, and mold base material, have a great influence on cooling rate. The higher the thermal conductivity of the mold material, the better the effect of transferring heat from the plastic per unit time, and the shorter the cooling time. Cooling method. The type of cooling system used in the injection molding process can also significantly affect the cooling rate. Cooling channels should be included in the design of the mold. The heat travels from the material to the mold, then to the water lines and air around the mold. Water-cooled systems, for example, are generally more efficient at removing heat from the mold cavity than air-cooled systems, resulting in faster cooling rates. Oil-cooled systems are even more efficient at removing heat. And cryogenic cooling systems, which use extremely low temperatures to cool the mold cavity, can achieve the fastest cooling rates of all. Cooling water pipe configuration. Closer the cooling water pipe is to the mold cavity, the larger the pipe diameter, and the more the number, the better the cooling effect, and the shorter the cooling time. Coolant flow. The greater the cooling water flow rate, generally, it is better to achieve turbulent flow. The better the effect of cooling water taking away heat by heat convection. Nature of the coolant. Viscosity and heat transfer coefficient of the coolant will also affect the heat transfer effect of the injection mold. The lower the viscosity of the coolant, the higher the thermal conductivity, and the lower the mold temperature, the better the cooling effect. Plastic selection. Plastic refers to the measure of how quickly plastic conducts heat from a hot place to a cold place. The higher the thermal conductivity coefficient of the plastic, the better the heat conduction effect, or the lower the specific heat of the plastic. The actual melt temperature is easy to change, so the heat is easy to dissipate. The heat conduction effect is better, and the required cooling time is shorter. Processing parameter setting. Higher the material temperature, the higher the mold temperature, the lower the ejection temperature, and the longer the required cooling circuit fill time. Design rules for the cooling system. Design cooling channel should ensure a uniform and rapid cooling effect. The purpose of designing the cooling system is to maintain proper and efficient cooling of the mold. Cooling process holes should use standard sizes to facilitate processing and assembly. Cooling system design parameters. When designing the cooling process system, the injection mold designer must determine the following design parameters according to the wall thickness and volume of the plastic part, the location and size of the cooling hole, the length of the hole, the type of hole, the configuration and connection of the hole, and the flow rate and heat transfer properties. In general, the cooling rate in injection molding is a trade-off between strength and dimensional accuracy on the one hand, and surface finish and shrinkage on the other. For parts that require high strength and dimensional accuracy, a faster cooling rate may be necessary, even if it results in increased surface defects and shrinkage. For parts that require a smooth surface finish and minimal shrinkage, Several techniques can be used to control the cooling rate in injection molding, including the use of thermal barriers such as insulating materials or cooled cores to slow the transfer of heat from the material to the mold cavity. The use of varying mold temperature shear different sections of the mold are maintained at different temperatures to act to uniform cooling rates across the part. Conclusion. In conclusion, the cooling rate in injection molding refers to the rate at which the material is tensile test bar cooled and solidified in the mold cavity. The cooling rate has a significant impact on the mechanical properties, dimensional accuracy, and surface finish of the finished part. And it is influenced by factors such as the material being molded, the size and complexity of the mold, and the type of mold cooling line system being used. The appropriate cooling rate for a particular injection molding application will depend on the required properties of the finished part and the trade-offs between strength, dimensional accuracy, surface finish, and shrinkage.